Hey there guys, we are back again today and we have exciting stuff. So here you can see on the table is the router sled. Again, not actually using these pieces of aluminum. We're going to use full sticks, but I got it assembled here just so you can see it. I've got it fully assembled just because first thing I want to touch on with it is definitely, so it's tall enough is what I'm going to say. It's tall enough. I'm not really concerned about not being able to fit the stuff underneath it because again, I'm only doing ½ inch. Well, it's going to start out a little bit more than ½ inch probably, but nominally ½ inch and then just facing that down to be flush. So I've got about an inch in here. It's one of those things. This is 2020, 2020, and then it's held up a little bit higher on this. So everything's lifted up by a little over 20 something, 24, let's say, millimeters, which is about an inch. And then, you know, obviously, I do lose a little bit because of these bolts on the bottom, but I think we got the clearance. So that's the first thing to talk about. Otherwise, this thing, just a matter of printing a couple test pieces to make sure that everything was right, which is a good thing because, as you can see in the difference here, I had this thing turned the wrong way. You will recall that I said we wanted to have the 82 millimeter one going in Y direction, I believe I said. I think I got myself backwards because one of these things, I looked at the CAD again after I realized that, well, basically, let me point out why that was. You see this screw knob in the back? I can take that screw knob out, but there's also a piece of plastic around it. So just to avoid having to design around all that and to have, you know, and to not have to worry about it, basically. I wanted it turn this direction, but for some reason in my brain, and again, this is what I'm saying, even when I went back to the CAD, I was still mixed up. I had it turned the other way. So now the screw knob and this extra jut of plastic back here are both out of the way and not interfering with the tray, with the gantry. So that's the first thing. Second thing to note is, I don't know if you'll be able to see this. I don't have this all bolted down for the record. This is just sitting on top of here. It's not bolted down yet. But second thing is, and again, not sure if you'll be able to see it, but you'll recall me saying that there was a potential that this would start to bend down, that the weight of this would bring it down, flare it out. That is happening, but it seems to be more or less at its limit here, and I'm assuming there's a couple reasons for that. One, it's only going to pull just so far against these wheels, and maybe I can torque this in. I didn't actually try tightening this nut up to see if we can take any of this out yet. I wasn't terribly concerned about this to begin with, that's why I haven't, but I can try turning the eccentric nut in here to kick everything a little bit tighter and therefore take some of this out. The other reason why I don't see it flexing any more than it already is because obviously this plate is super tight well, not super tight, it's snug. It's snug inside of the tray here, which means that physically the plastic would have to start shearing down here in order to flex more. So that's not happening. I'm not terribly concerned about it. It doesn't appear to be flexing particularly much at all. It flexes a little bit, I will admit, but one of those things, just be careful as I'm using it. And it really shouldn't cause that much issue on the surface. And again, this is just getting it roughly planed down so that I can come back at it with a sander. That's the entire point here. So otherwise, looking very happy with it. I will say, actually, one more thing. Obviously, this could be mitigated. This whole entire situation could be mitigated by throwing some supports in the angles here so that they don't want to. So, for example, throwing a triangle in here, just a cross beam, would help it from not flaring like this. And likewise over here, this flare inwards right here. Again, it's getting stopped by this, but adding, you know, I can bring this out so that we still have room for these guys, and then adding some support on the inside to stop it. There are ways around it, but I am not concerned about it, like I said, which is why I'm not doing anything about it. Now, as I stated, I had to rotate this, which means that I cannot actually start using this right now because, as you can see here, it changed the width. So this was the first one I printed, and then I changed this guy. Basically, let me back up. I printed this first test piece, and then while this first test piece, or after this first test piece got done, I started printing this guy. This shorter guy. And then I found out, oh crap, I gotta rotate it, and instead of stopping this guy, I was just stupid and let it finish. I'm saying stupid because there's actually, well, to be fair, it saved me time. It saved me a little bit of time. It potentially saved me a little bit of time, I should say. The place where it potentially saved me a little bit of time. Oh, actually, that's the other thing that happened. So one where it's not actually just this. It's not actually just this 90 going to 90 across here instead of 82. I also added a millimeter of space between this wheel and this wall. I had not added that in, and I realized it when I went back to modify this cat up here. I re-looked over everything. I should, you know, one of those things. You don't want the wheel scraping against the inside of the plastic here. So I added a little bit of gap there to give breathing room. So between those things, that's why this is so much bigger. So anyway, the reason why this potentially saved me some time is had I found an issue with these gantries, then I would have been able to fix it before I started printing these guys. As is, it did not actually have any real issues. So technically, yes, it was a waste of time and a waste of plastic, but it was good to at least check. Now, on to these wheels, just because there's something I didn't say. The way I designed this was a much more visual way of designing these wheels, where I aligned the wheels and then drew the gantry, you know, straight across. The fact of the matter is that is entirely not necessary. I just did it that way because it was a visual, easy to see and understand way of doing it. Basically, the way you would make any gantry is you would just take the distance between wheels and the extrusion, just calculate that one, and you can see here, back to, I said there would be some, where's something to point with? Yeah, the pencil works. I said there'd be some overlap in here, you know, where the wheel sticks inside. So basically, account for that a little bit if you want. Maybe add an extra millimeter, or subtract an extra millimeter, but take your distance between wheels and then just space this out. Basically, you draw a cross on your sketch, set this cross, this up and down piece, to the distance between wheels that you calculate. So the diameter of this wheel plus the extrusion. Technically it's half this and half this, but you know, one diameter of wheel plus the extrusion. And then if you want to add a little bit in for that guy, for the little bit that's sticking inside the track, you can. And then you could even add a little bit more, just because again, we use eccentric nuts, so that will allow you to adjust in if you need to. Point being is that that is a much easier way of designing these gantries than getting all the wheels aligned and mirrored over and then taking projections. Again, I did that specifically because it was easier to see, and I just felt like it was visually more demonstrative for the stream. But in the future, if I ever make any more of these gantries, it's just wheel diameter plus extrusion plus a little bit of leeway if you want to, plus or minus, because again, you got a little bit of you lose a little bit of diameter on the inside of the tracks here, but you also have a little bit of swing from the eccentric nut. So that's that. That's how I will be designing these in the future. I just didn't, again, for this specific project to demonstrate. Otherwise, once I get this new plate printed for this guy, well, I'm going to start assembling it in the garage today, just so that it's ready. Probably by the time I get done assembling it, this plate will be done. And then I can go ahead and start the next print and then go back out to the garage, and start using it. And that will be fun. Lots of fun. Anything else for this project? I guess the only last thing I will say is the tie downs, the hold downs are working just as well as I thought they were. You know, this is rock solid. I'm going to break something if I try pulling it out, so these little hold downs working exactly as I hoped they would. So that should be everything. I guess the one last thing, because I'm talking about the tie downs, obviously these bolts are sticking out a little bit more than I would like them to. One of those things, we're going to have the nuts on this outside anyway. If this was optimized, these bolts would be a little bit shorter, but these are the size bolts that A, I have, and B, allow me to take these hold downs on and off, like loosen them up and remove the router without having to take the nut completely off. So that's why these bolts are this size. Again, I lose a little bit of cutting space because of it, but it's a trade-off that I'm willing to make. So yeah, that would be everything. Next, don't know if you saw this guy in the thumbnail, kind of hidden there, but you probably did see. Oh, actually, sorry. There's one more thing. The eccentric nut over here, the hole for it, I left at 5mm in the sketch. I went back and changed that to 7mm. 7mm. Do I have an eccentric nut here? I'm not seeing one in my immediate vicinity, which means that I put it away, which is good. Oh, actually, I take it back. Eccentric nuts were sitting on the shelf, not put away, and it, whoops, sorry, not put away where they should be. So, eccentric nut has this little exert, whatever you want to call it, nub that goes into, gets pressed into whatever you're inserting it. And that is 7mm. That's not 5mm. 5mm is the bolt that goes through it. So that 7mm, these holes need to be opened up to 7mm, which I did in the CAD, and then printed it. And actually, now that I'm back on the CAD, just for the record, this guy got printed like this. So you'll see that this is a little rough around these holes, and I went and re-drilled out all the holes just so that they were easier to use. But this is how the print actually got printed, straight up and down like this, because that's the way it's happiest being printed. Also, it's nice printing in this direction just because everything's gonna, in theory, be held, you know, everything wants to break this way is what I should say. So if I had printed it straight up and down like this, or upside down, the opposite direction, these areas where it's flexing, here and here, those would be more prone to breaking because they're in line parallel with the layer lines. This way, printing it in this orientation, the layer lines are now like this, which means that they're perpendicular to these joints where it wants to break. And yeah, it's just better that way. So not only does it want to be printed like this, but it's also better physically for the object. Anyway, back to this guy. Back to this guy, which I will be continuing to print after this plate gets done. One of those things. I had like an hour to print, you know, an hour for dinner, you know, so I went ahead and printed this guy up really quick rather than reprinting the plate, which was going to take 2 hours. So, over to Fusion, now that we're done blabbing. So, as you can see, this looks a lot different than the last time you saw it. The problem that I did not feel like tackling with this was that in order to get the spring in here and have this ring actually do something, I needed a roof. And I did not want to make a hollow cylinder, because printing that would just be an absolute nightmare. Printing a hollow cylinder would be a nightmare, so I needed to make it in multiple pieces, and that's what we ended up doing. So I came back, made it in multiple pieces. There's no reason, once we get this roof in here, that we also need a wall around here, so that's why this yellow part right here is now open. You may recall in a previous, actually, let me go ahead and just pull up the previous version. Prototyper, and right there. Alright, so this is what the previous version looked like, as you recall, with the walls up here. There's no reason for the walls in the new version, so let me go ahead and close this router sled. I didn't actually do anything here, right? Yeah, I just hid something. Okay, cool. Alright, so no sense for these walls on the outside at this point, so that is why it is now open. And therefore, because I also didn't need the walls to feed into the knob, I was able to make it smaller. I didn't need all the plastic around the edges. So it shortened up and did that, and then I put the roof in, which is the way it was supposed to happen. This all is held together using the 2.5mm bolts going all the way through. One of those things, I just got to make sure I have long enough bolts, which I'm pretty sure. Let's double check really quick. So I'm going to turn the knob off really quick and measure that. I assumed I did, but yeah, 16mm. I definitely have 16. Well, it says 16.6. I have 20s. I know for a fact that I have at least 20s, and I think I might even have up to 30. So we are definitely clear on that. So 2.5s will drop through the limit switches and also hold all the pieces together here. So we got that plate that you know about, this new roof, quote unquote, which will hold the spring on the inside on this shaft. Let me turn this back on. So this spring goes on the shaft like we were talking last time, and this keeps the spring in compression. So the spring will push against the yellow plate and push against the roof right here. And as this knob turns, again, it will pull the spring up, compress the spring, and the spring will want to decompress and pull it back down to center. Again, that's how that works. So there's that. I'm going to really quick touch on this. So as you can see, I went around the back with this like the other button. I did not do that because I thought it was the better way of doing it, but rather because this is going to need to be printed in this orientation, as you can see, because all my features are going up this way. I don't want to be printing it in this orientation. Even if you imagine this isn't here, this is not an overhang you want to be printing right here. So we want that round flat part, the largest part, being on the print bed. And therefore, had I tried to T-nut it right in the middle here, well, I mean, I did. I looked at it briefly and I said, nah, you know what, this is going to be too much of a pain in the butt to smooth out in order to get it to the point where I can print it. Also, the other, without serious overhangs, in order to get the arc correct so that it doesn't overhang too badly and also have space for the T-nuts, that was the problem. The other problem that is less obvious is actually getting it put together. So if the T-nuts were going upwards like this, right, then you got to reach your hand inside and tighten those T-nuts down inside of this half cone, right? And that's just a pain in the butt. So move this out here so you can see that as this prints, it all prints vertically, so that's perfectly okay. There's no problems here. There's no overhangs. There was a little bit of an overhang here. I just used the chamfer tool to pull that out. So if I take a step, yeah, actually that was the last thing here. So if I take a step back, you can see I had a little bit of overhang here. Just chamfered that out to get rid of it. And everything should print just fine. Obviously the holes will be a little bit messy, but that's not that big of a deal. Otherwise, anything else to say about this? I did, you can look at this and say, okay, how wide does this need to be right here in contacting the extrusion? I figured this is enough of a lip. It's on one of those things. This is maybe a little bit more like personal preference, but I figured this is probably stable enough in my opinion. So that's how I left it. And otherwise, all this stuff that you're seeing right here are just simple lofts. There's just that loft from the flat face right here up to the side. That's the loft, and then this is a loft there to there. So you guys have seen me do plenty of lofts, so I don't need to explain that guy. Very simple. Now on to the knurls. I said there's a couple different ways that you can design knurls, and I just ran through very briefly one thing. So let me get back to the knurls right here. Alright, here's the other way to do it, which I decided to go with. So basically you can decide how many knurls or how many like troughs and naders you want on the knurls. I went with 200 here. We have 360 degrees, so I just did 360 degrees divided by 200 to get an angle between the center of the trough, or the center of the peak rather. I think I called it trough and nadir, but those would be the complete the same, you know. I'm looking for opposites. So the top of the arc here, and let me just draw in this actually would be like this, and basically you can see it's gonna do something like that. Okay, so the bottom part right here and the top part right here, one of those is now 1/200th of a circle. That's how I set it right here. And then obviously this is just mirrored over basically, because this is a tangent and this is equal. This circle is tangent and equal to, well, equal to this guy, tangent to that guy, I should say. So therefore this ends up being a mirror angle to the other one. So that is what I set, and then once I have the angle, remember I said you could set a couple different things. You had a couple different variables to work with. So when you set the angle, then you can just go ahead and set this size right here. There is a limit to what you can set it based on the circumference, but I just picked a number. I played with a couple numbers and then picked the number I like best, which was 1.5, and then these automatically get sized based on this angle and this circumference right here, or diameter, this diameter right here. So that did that, and so you do that in order for this method, and then the only thing you need to do is make sure when you do these, because I did the full, so this is my big circle, right? And then these are my two little circles, so that's one full revolution from top to bottom to top to the center top, right? So that's one full revolution, but I was counting the angle as half of this, right? The angle that I measured was only from midpoint here to midpoint here. So since that's half, I need to go, because that's half and I extruded double that, that means I'm going to have half as many as that 360 divided by 200, which ends up being 100, right? 200 divided by 2 is 100. So that is how that works. So first you can set the diameter, set the number of knurls you want, and then set the size based on what looks good. And then after that, you take the number of knurls that you want divided by 2 if you're going to extrude the whole entire thing. Again, that's the easiest way to do it in my opinion, in order to get a good look at it. And in order to get a good look at what it looks like, that's the easiest way to do it. And then again, you just pattern that around half the number of knurls that you wanted to, or half the number of half knurls, I guess is how I should say it, in order to get the correct number of repetitions around the circle. So that is the other way of patterning a knurl around the, or I say the all the time, and I always correct myself. It's not the other way, it is another way of doing it. Again, 1.5 million ways. So that would cover all the changes I've made to this guy in that case. I guess last thing to say is obviously the second that I put this lid on here and get rid of the walls on the lower part, then it helps for the knob. Whoops, I'm gonna have to come in here and hit bodies now. It helps for the knob to have something to ride on. It technically, so long as everything is rigid, so long as this shaft right here, this blue shaft right here, is rigid inside of all these pieces, then it's probably not going to wobble, but it is a little bit more steady to have a lip on this top piece for the inside of the knob to rotate around. It adds some more security to it, and it won't wobble as much. And again, with all the pieces that's passing through, 1, 2, 3, it probably won't wobble to begin with, but it just gives you a little bit extra. So that's why this has a ridge on it. And that concludes all the changes we made to the bi-directional controller. So like I said, once I head out to the garage to start putting together the router sled, when I do that, I will go ahead and get this guy printed and then assembled, and then we can start playing video games again. As for other streams this week, again, I had my list. Now, the rails, I said that I might do the rails stream for the deskettes, whatever the heck I was calling those things, yesterday and last night. I figured I might squeeze it in, and that obviously did not happen. And the reason that did not happen, and actually let me go ahead and pull up my model for the desk and desk insert shelving. So I already had this modeled up since forever, and these bottom parts are the parts that I'm working on making. This cage right here, I'm still not sure. Well, it's one of those things. I think it is necessary to have there to make sure stuff doesn't fall off. It's not necessary for the arcade prototype thing, just because everything is bolted down on that thing. But for any other projects that I put in here, I will have to build fences or something of the like. But my point being, these 15 inches that I keep on referencing whenever I talk about that, that's the outside of this cage, right? That's not the in-between of the desk. So between the desk and the wall, I have about 5/16 of an inch. Or, I'm sorry, 6/16. 3, no, that's just, wait. I had 5/8. I could have swore I had 5/8 is what I measured. That does not look right. Anyway, point being is that I have very little space in here. Is this also 3/8? Alright, it's saying I have 3/8 on both sides. I do not recall that being what I measured. I thought I only had 5/8, and that would be 5/16 on each side. 5/8 overall. 15 and 5/8 is what I should be saying. So 15 and 5/8 minus the 15 inches is obviously, what you call it? 5/8, and then divided in half is 5/16. So that is very little space for rails. I was considering, and the reason I said this stream would be really easy, I was considering just doing rails underneath, but I don't really like that idea. So rather than rails, what I'm thinking of doing is putting inserts into threaded inserts into the sidewalls, and then using my 623s, my 623s. Where's a container that actually has bearings in it? So I'll pop back over to the camera just so you know what I'm talking about. My 3mm ID bearings that I use for all my stuff. So I'm thinking about using these as rollers instead, in place of the rails. So these would be actually more or less mounted exactly like this, with the shelf feeding onto it exactly in this, like this. So if you imagine this being the shelf going all the way across, on the front end I'd have a set of 3 like this. That way it doesn't want to wobble until you're very, nearly out. So in other words, I've got a good 2 foot of shelf already sticking out here, so you better have your hands on it. But up until this last couple of inches, and again, the spacing on this is not exact, it may even be tighter in. Point being is that I have support in the front here, and then I would just throw a couple more along the length of it, like let's say another 2 or 3. Not necessarily in triangle shapes like this, probably just underneath, because again, the triangle shape is only necessary to keep it in line, so you only really need the triangle shape at the very front. You don't really need it in the back. It can just sit on top of bearings anywhere behind this one. So I think that's what I'm going to do. I'm going to go ahead, get threaded insert, 3mm threaded inserts, screw these guys into it, and then honestly, it's one of those things I may even need to like Loctite these guys in just to make sure they don't go anywhere, they don't work their way out. We'll see what happens with it. But because that's not really something that gets 3D designed, because that's not something I'm going to make a CAD of, that's just going to be something that I just drill out the hole, put the threaded inserts in, and be done with. That's not going to be a stream anymore. So I'm not going to be doing the rail stream, because this is not something you design. This is just something you do, frankly. So that stream will not be coming up anymore. We still have the pixel art that I want to do, and that is, I mean, obviously it's one of those things. That is not going to be an educational stream or anything like that. I'm just going to hang out and make some art, is all I'm going to do. And I'm not much of an artist, which is why it's pixel art. I've done some pixel art before, so I feel at least comfortable enough with that. But there's that stream, and then I keep on talking about getting lights up in here. So that is going to be another stream this week, is designing the mounts for the lights. And actually, let me go grab them, because I made sure I knew where they were at. Alright, so these are the old lights that I had back in the day. And these are probably what I'm going to use. They're a little bit heavier than I remember them being, but it probably will work out the way I'm thinking it is. Anyway, that will be a stream, so look forward to that one. This right here is not stock, as you might imagine. That is me doing funny stuff with this, so I'm going to have to refigure out where the well, either commit to this wiring, to these spade wirings, either commit to them and wire it up separately, or figure out where this AC adapter went, because I do not believe it is in the box with the rest of the stuff. These were going to get used for another project. I don't know if I'm going to do that other project at this point, because it's been like 3 years. So that's what this wiring was for. This wiring was for the other project. Anyway, so those are the 2 streams for this week. Otherwise, obviously, now that I got the router sled, I'm going to start making the deskets. That's going to take a good bit of my time this week. Well, it's going to take a good bit of time once I have the materials. So, for example, I already have the one desk put together for this. I just took pallet wood, since I have much pallet wood left over from the project, and jointed that together. So I'll obviously level that with this guy, and then sand it, and that will be most of the time done. The rest, putting on a couple of coats of polyurethane, will not consume much of my time. However, I also, like I said, wanted to do some epoxy tables for desks. That will take a good bit of time. So, one of those things. that stuff can happen over time. You know, that can happen over the next couple of weeks, so that's not that big of a deal. So we'll see what I do for streams this week. I can't think of any other pressing issues, anything else, any other obligations that I really have to get done aside from, you know, obvious stuff like housework and stuff. So, yeah, I think that's it. I think that's everything for this stream. So, thank you for hanging out. And obviously, 30-minute stream is cool. Again, it was just getting caught up. So, yeah. As always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.